Leveraging Geospatial Python for Environmental Consulting by Berg for ICT 4902 Capstone Seminar. In order to solve geospatial problems at a low cost, existing Python programming modules should be used to develop custom spatial applications. This topic relates to my field of study because I am a GIS specialist and an environmental consultant. I use GIS software on a daily basis to perform spatial analysis and solve spatial problems. You're probably wondering what GIS is. GIS stands for Geographic Information Systems, and they are designed to store, capture, manipulate, and analyze geospatial information and data. One of the most popular examples of a GIS is Google Maps. Google Maps stores several data layers in a large database, and those layers include roadways, housing, retail establishments, and satellite imagery. Those layers are then displayed to the user, and the user is able to conduct analysis between point A and point B. You've probably used GIS or Google Maps to get directions to a friend's house or get directions to a restaurant, etc. Here's a screenshot of Google Maps and how it can be used by a user. Environmental consultants use GIS technology to better understand the spatial world. Environmental consultants come alongside many organizations to help them use GIS technology, and they can range from the federal government to housing organizations. Environmental consultants use GIS software and technology to perform analysis, create spatial products and programs for a client to improve their profit margins. They could come along. Spatial products could be map products, web map products, analysis products, etc. GIS technology, however, can be very expensive due to the high cost of licensing commercial software. As a result, some environmental consultants may unfortunately overlook GIS software and its contributions and may try and find an alternative way to supplement GIS analysis. Python programming is an open source programming language that has several spatial modules that can be assembled to create custom programs to conduct geospatial analysis. These Python program modules can be leveraged by environmental consultants to create custom software and increase the value of their environmental projects. My literature review focused on three main topics: existing open source software, existing commercial GIS software, and geospatial Python libraries. Open source software is what you think it is. It can be defined as software that is freely available to the public, free of charge. They can do whatever they want to the source code. They can manipulate, repackage the source code, and individuals and organizations that develop open source software will accompany that software with a general public license. The general public license gives people who use that software free reign over it with some limitations. Open source software exists because a community of users support it and regularly contributes to its source code. In GIS, Open Source Geospatial Foundation is a non-profit organization that fosters the development of geospatial technology. They foster the development of web mapping technologies, desktop applications, and geospatial libraries, many of which we will go over. GRASS is one of these. It is a software suite that is used for geospatial data management, analysis, and image processing. The software was originally developed by the United States Army, but since its original development has been released to the public and sponsored by OSGeo. Here you can see their website where you can freely download the software. It is available for many different operating systems, and it looks like that. Quantum GIS is another open source GIS software. It incorporates other open source GIS softwares like Grass, Saga, GDAL, and F-Tools. There are many extensions for Quantum GIS. They are desktop, web client, server, and Android applications. Again, Quantum GIS is supported by GPL. Saga is not necessarily under the OSG banner, but it's a very important open source GIS programming application. It implements GDAL and Prog.4, which are both open source GIS-based programming modules. The definition of proprietary software is any software that you can purchase from an organization. When you own proprietary software, you cannot legally modify it or repackage the source code in any way. Basically, when you purchase proprietary software, you are just you're paying a fee to just use the software. You do not actually own it. Major proprietary GIS software. The largest is Esri, Environmental Systems Research Institute. They control about 40% of the market. They have web applications expanding from desktop applications to server applications to mobile applications. And the licensing fees for a desktop application cost about $1,500 to $7,000. And for using ArcGIS can range from $5,000 to $40,000 for lifetime use. Quickly show you their page. Very sophisticated software, very effective software, and very widely used in the GIS community. MapInfo is another proprietary software that exists on the market. They largely focus on desktop application development, and the cost of a single application ranges from about $2,000 to $2,500. Erdast Imagine is another GIS software that is largely used for remote sensing, which is the study of aerial photography and images. The latest versions of this software has incorporated Python programming in some of its geoprocessing tools. A single license for this will roughly cost about $8,500, and that's for term use. GIS consultants are highly dependent on software to create cartographic exhibits, create spatial databases, manage spatial data, build web-based applications, and conduct geospatial analysis. Since GIS consultancy is a niche market, the cost to develop software is high, and therefore it is expensive to the users to use. That's why the licensing fees are so high. Here's a short list of some of the Python modules that I examined in depth for my Capstone project, and I will go over them. GDAL, first off, in GIS there's two major data types: raster, which is image, and vector, which is points, lines, and polygon files. And GDAL is a translator. Essentially, it can read from 81 and write to 41 different raster formats, and it can read 27 and write to 15 different vector formats. It was originally written in C++, but there are bindings available for Python. Here's an example of some code that uses this GDAL library. PyProj is a Python wrapper that we saw that was used in one of those in the open source software Saga. It has two classes, Proj and Geo, and this open source Python library performs cartographic transformations, calculates great circle distance and angle calculations. Here's an example of how it is used in Python. You can see here that the spatial references for this particular location are loaded through this PyProj module. Shapely is another Python module that is used for the manipulation and analysis of vector geometries. You can see the different geometries of the features that this module uses, and it again, here's an example of the coordinates for a vector file being used in Python. MapNIC is a module that takes geospatial data and renders it to a clear image. MapNIC is often used for web-based applications, so it takes rendered GIS images and converts them so they look pretty on the web. There are many lightweight Python modules. Python Imaging Library is a library that is used for raster data management, similar to GDAL, but it is lightweight. PyShape and PyGeo are modules that support reading and writing to vector GIS files, and there are a few others. The reason why lightweight modules are important is because when compiling a software program that you may create, they take up less memory, physical memory, in the program, and therefore your program that you create is easily installed and transferred to different environments. The solutions that I examined for my Capstone project was a pure Python-based GIS application, which is a GIS visualization program. This program essentially visualizes vector and raster GIS data and performs some basic GIS analysis on it. I also looked at a few projects that implement geospatial Python programming. The GIS visualization project that I examined is a multi-level package which has two main packages, a vector package and a raster package. This is important because since these are the main two data types that GIS uses, it's important that a module is dedicated to each so that the program can work with each data type separately. Vector and raster modules are each accompanied by a data loader and saver methods within their package structure. As you can see, here's the package structure, and these modules are used to analyze, load, and manage and save the data that you bring into the GIS visualization program. Here's an example of the sample code written in Python that makes use of all the different lightweight Python modules that I referenced earlier. Here's a window of the software in use, and here you can see some vector files that are loaded into this window in this GIS environment, and the associated data can be analyzed in this environment. An article that I read for my Capstone was called Python Coding for Geospatial Process in Web-Based Mapping Application. This essay describes how open source Python modules are used in part to create sophisticated web-based GIS application. This web-based application was developed to facilitate the identification of potential areas for high resource concentration for low or no carbon energy resources. But they conducted analysis, and using Python they were able to display that analysis in a web-based environment, and they used the following modules that you can see here. This is another project that I looked at. This one was conducted in India, and it was similar to the one that we just talked about. They were able to conduct an analysis and show that, and conduct an image analysis and show that in a web-based environment. The advantages for using open source software and creating open source software, first off, for cost savings, you're able to avoid having to pay licensing fees, which makes it easier for contractors to implement the technology. There's no dependence to the vendor. They're able to gain advantages by having open standards, meaning that you're able to package and repackage the code and source code of other open source modules as you please, and as a result of that you're extensively able to customize the software if you have the know-how. The disadvantages to using open source software are knowledge barriers. Sometimes when trying to use an open source software, individuals won't have the knowledge and know how to use it. They won't be able to implement it in a commercial setting, and because they're not familiar with a particular open source platform, this may result because they may be more familiar with a widely known proprietary software. Another disadvantage stems from proprietary GIS software has a large portion of the market, which kind of influences the knowledge barriers. Individuals are more familiar with proprietary software and therefore don't know how to use open source software, and stay in that lane and stay with proprietary software. Sometimes the cost of switching from proprietary software to open source software are very costly for organizations, in particular organizations that have business processes that are dependent on the proprietary software. So sometimes the cost of switching to a equivalent open source option is not possible because they are dependent on the proprietary software and the technicalities that it has for their business process. Another disadvantage that discourages organizations and individuals from using open source software is open source software, especially when it's first released, can be unstable, and sometimes organizations may choose to opt out of using an unstable solution and stick with and pay for a proprietary software solution that is stable. The recommendations that I reached at the end of my Capstone project is that organizations and individuals should adopt open source geospatial technologies for environmental to support their environmental consulting business practices. More often than not, I found that existing open source GIS platforms are comparable with leading proprietary platforms, and environmental consultants should consider using GRASS, QGIS, and Saga. Python programming requires lots of technical expertise, and maybe some GIS consultants won't have that, and so they should first look into what existing open source software solutions exist, and be able to implement those software solutions for their GIS-based projects that way. Python programming should be used in cases where consultants need to develop customized tools and applications. The existing Python modules are great for that. Here are my sources. I just wanted to point out that some of the graphics that I used were from Eric Westra and Kareem Berg. These two sources here from these books I relied heavily on. So, thank you for taking the time to listen to my presentation today, and I hope you have a great day. Thank you.